A little bit of review to start with. Last week we learned what a radian was. We learned that a radian was the angle when you had one radius along the outside edge of your circle. So if you have a circle right here with this as its radius, then when you have that same long length along the edge of the circle, that's the definition for what one radian is. And if you remember the triangle that I had, the equilateral triangle getting pushed down, we found out that one radian was a little bit less than 60 degrees. We found out that it was approximately 57.3 degrees. But if a radian was one radius around the outside of the circle, since we already have a formula for circumference, which means that there's 2 pi radiuses around the outside edge of a circle, we found out that there was 2 pi radians in a whole circle. And from that, we can now convert between radians and degrees, because we know that 2 pi radians equals 360 degrees. And so we know that pi radians is equal to 180 degrees. Now, this statement that I just put here can be a little bit confusing because pi itself is not equal to 180. You know that pi is 3.14. But pi radians is equal to 180 degrees. Unfortunately, there's no symbol for radians. So we use a degree sign to say that we're using degrees. We don't have any sign when we're using radians. And so I think when I wrote this statement, it can be very misleading because it looks like 3.14 is 180 degrees. You need a unit with that. 3.14 radians is 180 degrees. So they're different measures of measuring angles. So what we're going to do here in example 1 is we're going to work at how do we change from degrees to radians and radians to degrees. So in A, we have 170 degrees. We want to change that to radians. Now, there's a number of techniques that we can use. If you forget these techniques, what I suggest is start with what you know. You can make a little chart here. If you know that pi radians is 180 degrees, what you can do is you can find out what one unit is quite easily. In this case, I'm going to find out what 1 degree is equal to. And I can get that by dividing by 180. But if I divide this side by 180, I'm going to need to divide this side by 180 as well. And so I find out that 1 degree is pi over 180. And some people remember that. They remember that 1 degree is pi over 180. And then when they want to figure out 170 degrees, well, all I have to do to go from 1 to 170 is multiply by 170. I can do the same thing on this side. And 170 degrees is equal to 170 pi over 180. And you could reduce that. You can see you can cancel out the zeros. You can get 17 pi over 18. But you can leave it like this, unsimplified as well. So some people remember what 1 degree is. And if you remember what 1 degree is and you want to convert 170 degrees to radians, you just have to multiply by pi over 180. And so this is how many radians 170 degrees is equal to. Now, it doesn't seem bad for remembering that, okay, so if I just remember pi over 180, then I can do that. The part where it gets tricky is 1 radian is 180 over pi. So then they're so similar that you can mix them up. So I like this idea of starting with what you know, that pi radians is 180 degrees, and then you can figure out what 1 radian is or 1 degree is, sort of a unit cost, and then go from there to figure out the other angles. Now sketch, let's see, is there anything more? It says give it as exact measures, so we've done that as an exact measure, and to the nearest hundredth. So we'll take out our calculator and just type this in. Again, if you have the fraction button, start getting used to using it. 17 pi over 18, 2.97. 2.97 radians. All right, part B. Now we have negative 12 pi over 11. So just like degrees, when an angle is negative in radians, it means it's going in the clockwise direction, starting at the positive x-axis. Yes? Yeah, I can go back.
Is it 18 or 180?
When I typed it into my calculator, I simplified the zeros and wrote 17 pi over 18. You could also type 170 pi over 180, but those are the same. So in part B, we've got negative 12 pi over 11. And in the first part, it's asking you to sketch that. Now, the one thing you're going to find about radians, since you haven't used them as much, you're not as comfortable thinking about negative 12 pi over 11 as an actual value. Whereas if someone said, you know, how big is 220 degrees, in your head you probably got an idea what 220 looks like. If I say 12 pi over 11, probably in your head right now there's nothing. Just a big question mark. Just a, I don't know, how would I do that kind of thought. So we're going to learn those things. First of all, we're going to learn that if you think about going around the circle, you'd start at 0 degrees here or 0 radians there. Halfway around a circle is 180 degrees. In radians, 180 degrees, you now know that's pi. And all the way around would be 2 pi. So if we think about that, we can also figure out what 90 degrees is. 90 is half of 180. It's going to be half of pi. And down here, we'd have 1.5 pi, or 3 pi over 2. So this is where we're going to sort of start with. And we're going to sort of start with thinking about whole values of pi and half values of pi. First of all, when we think about negative 12 over 11, if you just think about that fraction in front, is that bigger than 1 or less than 1? A little bit bigger than 1. Is it bigger than 1.5? No. So for negative 12 pi over 11, we know that it's a little bit bigger than 1, but less than 1.5. And we're going in the negative direction, so we know that we're going to be coming around this way. This would be 1, and we're going to go a little bit bigger than 1. And this is what the angle of negative 12 pi over 11 would look like. If you wanted to imagine even more exact, because the denominator is 11, you're sort of imagining this section from 0 to pi being separated into 11 different sections. I don't even know if that is 11.
That's 9.
That's 9? We'll add another one there, another one. Perfect. There we go. They're all equally spaced, as much as we can imagine. And if you had split this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 equally spaced one, it looks like our line should actually be a little bit smaller even, because we need to go 11 out of 11 and then just one more 11th more, as an idea of how big this angle is. Now, if this was an exam, this would be enough to show that you know that it's going to end here in the second quadrant, and it's going around in the negative direction, and you've got the basic idea. Now we want to take this measure and figure out what it is in degrees. So again, we can start with the same thing. We can think about, well, we've got radians here, degrees here. You know that pi radians is 180 degrees. And if I want to find out what 1 radian is, I'd have to divide by pi. So I would do the same thing on this side and divide by pi, and I find out that 1 radian is 180 over pi degrees. So if you want to figure out what negative 12 pi over 11 would be, well, what do I have to multiply 1 by to get negative 12 pi over 11? Negative 12 pi over 11. I would do the same thing on this side. And now this is a little bit of math to do here. We're going to have 180 over pi multiplied by negative 12 pi over 11. One of the things I want you to notice is that these pi's will simplify. If we type this into our calculator, 180 times by negative 12 over 11. Mine is coming up as a fraction depending on what mode you're in. So this is the simplified as a fraction, negative 2160 over 11. But we wanted to know what it was approximately as a decimal. Some of your calculators will give you your decimal right away. It depends a little bit what mode your calculator's in. I have my calculator's mode set in math print, and it shows up right at the top. Some of you, you'd have to scroll down to the bottom to see that math print. That math print is really nice. If it is in math print and you get a fraction and you want a decimal, if you hit the math button, number 1 changes all decimals to a fraction. So if you get an answer that's a decimal and you want it as a fraction, that's really nice because it'll simplify it for you. Number 2 changes all fractions to a decimal. So if I put enter on this, it says take the answer you got, write it as a decimal, and I find out that it's negative 196.4 degrees. And when we look at our diagram that we drew, does that angle look like negative 196? Yes. It's gone past. Here's negative 180 and then another 16 degrees more, so it's ending in quadrant 2. So again, some people just memorize that 1 radian is 180 over pi. Since you know that pi is about 3, well, it's 3.14, but if I'm doing mental math and I'm trying to divide 180 by 3.14, I would probably round and go, what's 180 divided by 3? 180 divided by 3 is 60, which makes sense if we think of our triangle, that a radian is close to 60 degrees. So when you're dividing by a little bit more than 3, you'll get a little bit less than 60, and that's where that 57.3 degrees comes in. So that's one way if you're having trouble remembering that 1 degree is pi over 180 and 1 radian is 180 over pi. Since they're so similar, I use the idea that if I do 180 divided by pi, it's like 180 divided by 3 and a bit. I'm going to get something close to 60, and I know that 1 radian is close to 60 degrees. So that can be one way that you can remember that 1 radian is 180 over pi, and then you can just multiply. You know, if I want to find negative 12 pi over 11, I can just take negative 12 pi over 11 and multiply it by 180 over pi. So that's what some people use to solve these degrees to radians directly. Okay? A shortcut for changing from radians to degrees And this shortcut only works if your original answer in radians includes pi, is the idea that I know that pi is equal to 180. So if I want to change negative 12 pi over 11 radians to degrees, all I need to do is change the pi to 180 degrees. And in doing that, you will get the same answer as before. And that's a really nice shortcut to use. So if I'm asking you, well, what's pi over 2 radians in degrees? Well, you know pi is 180. 180 divided by 2 is 90. That can help you switch in between those a lot faster. So the chart is great as a technique to start with. And then if you remember some of these, you might like these more direct methods to figure it out. Multiplying by 180 over pi or multiplying by pi over 180. And then in radians to degrees in particular, if there's pi involved in it, then you can just change that pi to 180 degrees. Part C.
Out of curiosity, when we finish this test, could we actually have pie to celebrate?
We could have a pie potluck.
Yeah, that'd be great.
That would be fun. So in this last one, it's changing from radians to degrees. Notice there is no pi in this one. It's just 7.5 radians. So you can't use that shortcut. You either have to use the one method where you take 7.5 and multiply it by 180 over pi. Type that into your calculator to get what it is. So this is just directly, so 7.5 multiplied by 180 divided by pi, 429.7. Or you could start with your chart. You know that pi radians is 180 degrees, and you need to figure out what 1 radian is. And once you figure out what 1 radian is, you just need to multiply by 7.5 to figure out what it is. And notice in this last step here, this green box is exactly what's happening there if you remember that 1 radian is 180 over pi. So you've got some decisions to make on how you want to do this. Do you want to take some time to remember that 1 radian is 180 over pi? Or do you feel better saying, I need my memory for all the other things I need in school, and it's like capacity, it's getting full. So maybe I want a method that I don't have to memorize stuff, it just makes sense. Then that works as well. Okay, questions to do for this one. 4, 5, and 7.